All right, hey, welcome back to the channel. Today I'm going to go over a deep dive on intrusion prevention systems and intrusion detection systems. This is kind of a continuation of my network security videos. So we're going to just go ahead and get started right on this because I would rather not have this video go on for almost an hour like the last video is that I made. I'm trying to give you guys enough in-depth knowledge to work with here without getting too far into the weeds. So let's just go ahead and jump right into it. So first I'll explain the intrusion detection system. Basically, it's this, you could think of this like a piece of hardware or software that monitors network traffic to pick up anomalies or any sort of suspicious behavior or anything like that. And it will basically log the activity and allow you to take some sort of action with it. Now, an intrusion prevention system, on the other hand, this is an IDS, except it allows you to automatically take care of the problem. And because I make my videos for home users, what I would really recommend is that you just go ahead and set it to IPS for your home network. You could do IDS if you want and then just have everything logged, but if you're just going to be running this all the time, I don't recommend people be neurotic about checking their internet logs or anything like that to see if there's anything going on. If you just have it set to IPS, then all of the threats that try to come up on your network will just get blocked. Okay, so as far as IPS solutions that are out there, there's quite a few different ones. Some of the more, especially for home users, the common ones that you'll end up seeing are Snort. This was originally developed by SourceFire, and then it later got bought out by Cisco. And the other open source option that you'll see is Suricata, which is, I would say, a little more powerful of an option than Snort, but they work perfectly fine. I don't think you really need to worry about whichever one you want to choose. They're both open source. Then there's a couple other, here's just a couple of other examples would be like FortiGate. This is a proprietary enterprise solution. Same thing for Cisco Firepower. Now, like with Cisco, for example, is Snort is kind of built in at the core, but then Cisco builds out Firepower. They've built out Firepower kind of on top of it with extra IPS features, so that's why I kind of consider it to be like its own thing, even though Snort is, like I said, they're kind of at the core of it. So let's go ahead and jump into how these IPS are able to detect threats. Now, the first way that they are able to do this is with something called signature-based detection. Now, the way that you could think of this, I'll just explain hashes here because it might make a little more sense. If you're a network security guru, don't be going down in the comments, oh, this isn't the same thing as signatures. Yes, I'm well aware of it. I'm just giving you an example, or giving people an example here of something that's kind of easy to follow along with. So let's take this example.exe up here. Now, the thing is you could kind of apply this as like example.pdf or whatever. So everything gets its own, so these files get their own hash. Now, this is an example of something called a SHA-256 checksum. Another one that you'll end up seeing is MD5. Now, the thing with these, so let's say, so this is the original file. Now, let's say you were to go make changes to this file. Let's say you make a change to this executable, or let's say it's a PDF and you go change a couple of characters around. The hash of this file, this unique string of letters and numbers, this will change completely. You could go in and change like two letters or two numbers on this file here, and this hash will completely change. So the way to think of this in regards to signature-based is that signatures are kind of like the same thing. Like a unique identifier gets assigned to a piece of malware, for example. So let's talk about that more. So signature-based will block known threats, and it will block if it's configured. So like I said, if you have it set to IDS, it's not going to block automatically. But if you have it set to IPS, it will block. And this also depends on the signatures because you can customize it. Let's say you only wanted to block some pieces of malware, but you didn't, like you wanted to block known malware, but you didn't want to block botnets, for example. Like, I don't know why someone would do that, but you can set up what it is that you want to block. Now, this will only block known malware or patterns, malicious patterns. So the thing is that this will not work with 0 days, and it will not work with new threats because there are no signatures for these pieces of malware yet. And so that's a downside. And then the other downside is that it constantly needs updates, because with signatures, let's say you're blocking a known malicious IP, for example. Now, IPs refresh quite a bit, they change hands quite a bit, so the block lists have to constantly be updated to drop old IPs, add new signatures for new pieces of malware that are coming out. So that's an example of signature-based detection. The next one is something called anomaly-based detection. Now this operates by kind of gathering a baseline of your network activity. And then what it does is it works by blocking anything that is a deviation from normalcy. So in this case, let's say you have an unknown threat or a 0-day trying to run rampant through your network. If an anomaly-based detection system is set up, is it can pick up, okay, well, this is out of the ordinary. This isn't normal traffic. There's something odd going on here. We're going to block this. And so the thing that makes these, one of the big pros of using these is that they are adaptable to the environment. The two cons of this is that you can get false positives with it, and it's resource intensive. So like with signature-based detection is you have signatures like, okay, I'm comparing what I have here to the signature. This is for sure a piece of malware. Whereas with anomaly-based it's required to dig a little deeper and figure out, okay, what's actually going on here. And then the other thing that you'll see here is something called stateful protocol analysis. Now this works off of something called state tables, which I will explain more in depth on a later video, because that's kind of a big thing all in and of its own. Like I'll cover it when I talk about stateful firewalls versus stateless firewalls. Now the thing with these is they are able to track network protocols across sessions. So let's cover that a little more here. So the thing with this is that it's able to detect small anomalies, kind of like anomaly-based detection over here, is it's able to pick up small anomalies. And so the other thing that it's useful for, as an example, is fragmentation attacks, which I'm going to cover those here pretty soon. So stateful protocol analysis is pretty good at determining what's what by using context of what's going on. And so let me give you a three-way handshake. I'll just briefly explain this. I'm not going to cover it in great detail, but just give you a brief explanation of what a three-way handshake is. So in a three-way handshake, you have something called a synchronize packet, then a synchronize, acknowledge, and then an acknowledge. And so let's take our client here who is trying to establish a TCP connection with a server. So this first thing starts off with the synchronize. So the client is sending over a connection request to the server with something called a sequence number, saying, okay, they're requesting a connection. Then the server responds with synchronize, acknowledge. So then that gets sent back basically saying like, hey, okay, I'm awaiting your next piece of data. And then the client sends back acknowledge. And then this establishes the TCP connection. Like I said, this is a simplified way of explaining it. An even more simplified way of explaining it would be two people trying to communicate, client saying, hey, are you there? The server would be, or the other person would come back saying, hey, yes, I'm here, go ahead. And then they start communicating back and forth, and a chain of communication is established between the two parties. So let's go ahead and talk about what it is that you can set these things to do. So the first one is alerts. Now you can set it up a few different ways depending on what it is and how you configure it. You can do emails, you can do logs, which you should do logs anyway. You could do things like have notifications sent to you somehow. No, I don't recommend people be neurotic about checking this stuff like I had already mentioned. What you could do is just have everything logged, and then like once a week just log in and check it, especially if you have IPS set up and you're just going to let it do its work automatically. This works out the best for home users. And I know I'm seeing comments every now and then come up on the channel of people that they come and watch these kind of videos, and this is an issue with cybersecurity content, is I think it kind of gives the impression that the sky is falling in regards to hackers. And like if you're visiting shady websites constantly, then yeah, I'd say you need to be more worried than the average user. But if you're just visiting benign websites and you just have normal web browsing habits, then just using a regular old router off of a box store or something like that works perfectly fine. There's no need to get all worked up and think that someone's going to hack into your network. My videos are kind of based more towards educating home users on this stuff, but also, like, let's say you want to build out a home lab and you want to learn about this stuff, then that's where information like this, I would hope, kind of comes in useful so you can kind of learn about this stuff. But again, you don't need to be worried about it. Like I said, if you just want to run a regular old router on your home network, then by all means, you're perfectly fine to do so. The IPS and IDS is really more applicable to enterprise and government. But like I say, you can set this up as a home user if you want to. It's perfectly fine. So then, besides alerting, then you have blocking. So for example, you could block single IPs, or you could block an IP range. So something like 10.10.10.10 from that range to, like, let's say 100.100, so on and so forth. So you could block a whole bunch of different stuff. Now, like I said, you can get block lists like that off of places like GitHub. There's people that compile these lists. They're constantly updated, so you just want to make sure that you're keeping your lists up to date, whether you update manually or you let the IPS update automatically. The other thing that these can do is reset the connection. So basically the IPS is in the middle. So let's say you have, well, I'll give this example here in other example here in a second. Basically, let's say you have a hacker that has been able to get onto another person's computer, the IPS detects it. What you can do is, like an admin, for example, is go in and reset the connection. Basically, it just drops the connection entirely. This is more useful for like a corporate environment where, let's say, someone on, like a security analyst, picks something up and just basically shuts everything down immediately. Then the other thing that you can do is just drop the connection entirely. So where this comes in useful is, let's say you have these two different devices here communicating back and forth, a hacker and a regular computer, and the IPS is here in the middle. So the IPS picks up this malicious traffic. One of the things that can be done is just drop this traffic. So it's like it got deleted, basically like it never existed. Where this comes in useful is, like, let's say someone like a security analyst picks up this traffic, like, hey, something odd is going on here, and so they just basically delete the traffic, and so it doesn't alert the hacker right away that something's going on, that they've been detected. Now let's talk about one of the big downsides of using an IPS, or not really a downside, but just something to be aware of, because everything's got its pros and cons. These tend to be pretty resource intensive. Now, you don't need like super insane hardware. Like if you're gonna build, let's say, a PF box or a PF Sense router, for example, something like a older Core i5 that's like, I don't know, 5-10 years old, and you could use like 4 gigs of RAM and like maybe a 128 gig SSD, like that would be super basic hardware. You could buy one of those old office computers off of eBay for like $50 or $100 or whatever they cost these days. Buy one of those and you would have plenty of resources to run it. But let's say you had like a crappy single core Celeron, I guess it'd have to be like a super old one for it to be single core, and maybe like 1 gig of RAM or something like that. If you try and turn on IPS, it will basically destroy that tiny little bit of resources. So let's say you have a 1 gigabit connection, you don't have enough hardware to be able to run IPS on all of that traffic. So your actual throughput to your device could go from, let's say, 1 gigabit to 400 megabits. That's an example of where you just need to make sure that if you're going to run this, that you have enough hardware capabilities to be able to do it. Like I said, you don't need anything insane to do this. You don't need like the latest and greatest hardware to be able to do this well. The other thing is deep packet inspection. So this all ties into each other, and I'm going to cover this on a separate video, like how to actually set up proper deep packet inspection. Now, some deep packet inspection is able to work with encrypted traffic like HTTPS traffic, and some is not. It depends on who makes it and how you have it set up. So for example, you could do unencrypted FTP traffic, or you could set it up so if you have your certificate set properly. This is a whole process. I'm just giving you like a really basic overview here. You could have it set up so DPI is able to decrypt all incoming and outgoing HTTPS traffic to pick up any threats or just scan and make sure there's no malware coming through. And I'm going to cover this more here in just a second. So that's something to be aware of. So IPS on its own, it's not going to be able to pick up encrypted traffic unless you have deep packet inspection set up with the proper certificates installed, which there is security risks to be aware of like that all on its own. But like I said, that's an entirely separate video that I will need to make to cover all of that in depth as far as like how to set it up and how deep packet inspection works. So let's go over just a few attacks here real quick, just because I want to give people an idea of some stuff here to be aware of as far as some ways that hackers can work around an IPS. So the first one, I very briefly mentioned this, was fragmentation attacks. This was in regards to the stateful protocol analysis up here. And so what a fragmentation attack is it's a malicious payload that comes across in multiple packets. So I'm just going to give you a very rudimentary example here, just like I said, to help make things make more sense. So let's imagine you were working on sending some sort of a letter with malicious intent over to someone, but you didn't want the mail carrier to know ahead of time. This is not the greatest analogy that I could give, but we'll just go with it. So let's say what you were doing is you were sending out small chunks of this through the mail. And so no one can get the full idea of what's being sent until the receiver has like the full letter, for example. And so let's say the post office was on the lookout for a malicious letter, but they're seeing these small chunks come through. And they're like, oh, okay, well, this seems pretty benign. So like, let's say you just send this little chunk here, and then this little chunk here, and then so on and so forth. So this would be like a fragmentation attack. So imagine these are all malicious packets here and they're being sent separately. This is something that hackers will use to try to work around security measures, because what these like signature-based detection, for example, is it will take a look at the whole picture. So you have your IPS sitting in the middle, going and scanning traffic, scanning these packets that are coming in. It's like, okay, well, this packet, okay, this is innocent. Next packet, okay, this is innocent. So on and so forth. And so then basically, like I said, very simplified explanation. So then when you get the whole picture here, where all of this is now on the, like, let's say the host machine, is then the malware is now, or the hacker is now on your computer. And so the countermeasure to work around this would, like I had mentioned already, would be to use something like stateful protocol analysis, where it will pull all of the packets together and analyze everything and say, okay, again, really simplified. I'm trying to keep this under 45 minutes like my last video, but it will take everything as a whole picture and say, okay, all of these packets put together are malicious. Block. So that is an example, and that's like an example of why things like anomaly-based detection, stateful protocol analysis are more resource intensive. The next thing is hackers that use encryption on the traffic they're sending through. So things like SSL and TLS. This is one of the weaknesses of IPS, because then you have to depend on deep packet inspection, which, like I said, I'll cover how to set that up in a separate video. But that's where you need to have something sitting in the middle, the IPS in the middle with deep packet inspection, to decrypt all of the incoming and outgoing traffic to see if there's anything malicious in that traffic. The other thing that can be an issue is things like polymorphic and metamorphic malware. Let me explain what these are. Again, it's going to be a pretty simplified explanation. So WannaCry was a really nasty piece of ransomware that came out, I believe, when this stuff first released. It ended up going and infecting lots of critical infrastructure, things like power networks, hospitals, things like that. Maybe it was a separate strain of malware. I'm pretty sure it was WannaCry was the one that was infecting like a lot of critical infrastructure and was really nasty, and it spread really fast. So polymorphic malware is where, so with polymorphic is it changes like its code or like how it's appearing and other parts of itself every time it goes to infect a new system, but basically the original way that the malware works stays intact. And so like basically any good antivirus out there these days, like Kaspersky or Defender, depending on what it is, go watch Leo from the PC Security channel if you want to see some ransomware tests. But things like Kaspersky and things like that are good at picking this stuff up. Now, an example of metamorphic malware would be something like Verloc or Vireloc. And what this thing does is, what it's able to do is every time it goes and infects like different systems, is it's able to change and rewrite its code. So basically, it's almost like it becomes a new strain of malware every time that it evolves. And so these both polymorphic and metamorphic malware are an issue for signature-based detection because, like I said, it relies on a signature of something that's already pre-existing. And so when something changes, basically you have to make a new signature for that. And so like Vireloc or Verloc or however this is pronounced, what this was able to do was go and infect people's computers. And one of the issues with this is like, it was able to infect it was able to infect a person's computer. And let's say you had a OneDrive, so you have two people here and they're inside of a business. Well, let's say there is a whole bunch of people inside the business. They're all using OneDrive, for example, or some other sort of file sharing system or whatever, and they're all sharing files with each other, is one person's computer. And this is also why it's so easy for an entire organization to get hacked. It only takes one computer. It only takes one person slipping up and doing something dumb to infect an entire network. So what Vireloc was able to do was go and infect a system, then was able to take its code and create like polymorphic malware and infect individual files. So it could infect files, and this was actually stuff that was going on with this malware, is that it was infecting files that were like being shared between organizations or like cloud services, so that one person, okay, and then this file then syncs to these other people, now loaded on those computers, and then that malware infects them. That's how entire organizations can be taken down with malware by just one strain of malware. And there's lots of other variants of metamorphic and polymorphic malware out there. This is just a couple of examples. Polymorphic is becoming pretty common. Metamorphic is a little more advanced to make. And so this is where you need something like heuristics to be able to catch this stuff. And this is why one of the reasons that like a good antivirus like Kaspersky or Bitdefender is able to pick up on this stuff is it's able to. So heuristics would be something like when an antivirus, for example, is looking at something and it's looking at it and saying, okay, is the behavior of this file, is something odd about it? Like, let's say the antivirus is able to say, okay, well, we don't have a signature for this, but it's behaving strangely. That's an example of heuristics where it's like, okay, something's off, something's not quite right, we need to block this. So those are just examples of things that are kind of a weakness for IPS systems. Like I said, you can work around it, what the threat is that the IPS is facing. But anyway, I hope this gives you a pretty good understanding of IPS now. Like I said, I could have made this seriously like a 2 or 3 hour video. I'm 25 minutes in here pre-editing on this. So like I said, I'm trying to keep my stuff from going into like an hour long, because I don't think a lot of people want to watch an hour-long video talking about IPS unless it was for they were taking the Security Plus exam or something like that, which if you guys want to see more stuff that's really in-depth, then go ahead and let me know. I think some people like the really long 45-minute videos, and I think other people click on it and they're like, holy shit, this is way too much knowledge in here, and I would like to have it dialed back. So like I said, I'm still trying to find a middle ground there. Anyway, that's going to wrap the video up. I got a lot of other stuff on networking coming out, not just network security. I also, one other thing I wanted to, if you're still, the 2 people that are still watching the video at this point, I'm not like specifically focusing on cybersecurity. I'm doing other stuff like just general networking topics or like Windows sysadmin topics. So like I'm going to cover a video on how to use Windows Power Tools, for example, or Power Toys, for example. So there's a lot of variation of content that's coming up. One of the things I like to talk about a lot is cybersecurity. So that's why, you're seeing a lot of cybersecurity content on the channel. Anyway, it's gonna wrap the video up. Shout out to you if you made it this long in the video. I appreciate it, and I will see you on Friday.